Everyone, welcome to my video. We are going to solve rod cutting problem, which is pretty common and important when it comes to interview. Here we are given length and of a rod and price associated with each piece of rod. So you can cut the rod in such pieces, any number of pieces, as far as your wide n equals to 8, and you get this price associated with that length. So if you do not cut the length, cut the rod, and it is of size 8, it will yield us 20. Then if we take 7 and 1 for 8, which will yield us 17, and 1, which is 18. If we take 6 and 2, then 5 and 17 again will yield us 22, which is the maximum in this example 1. Okay. When it comes to example 2, again the length is 8, but the prices are different over here. So if you do not touch the rod, do not cut the rod, it will be of length 8 individual, and it will yield us 20. If we take 7 and 1, then 17 plus 3 20. But what if we cut the rod into 8 pieces of length 1, then 1 1 1 1 1 1 1 1, which means 3 into 8, which will yield us 24. And in this example, this will yield us the maximum price which we can get. See, length 1. Okay. So again, a very important pointer over here is this is usually done in 2D DP matrix. And if you're doing in any language, let's say Java, C++, then it will get solved in GFG. But if you are doing in Python, forget about it. Because recently they have added some extra test cases, and 3 test case will fail no matter how hard you try. Okay, I've tried various times. So I have devised a method, or I can say I came across a method using which we can solve this in 1D DB matrix, 1D array of DB. Okay, not a matrix. And we won't even need to create the length array. Okay, so I created DP and initialize with 0 altogether. Then I will traverse through my length of rod. And now no choice over here, but I will have to put j in range I. So you can see it looks somewhat like I'm going towards sliding window, but I mean maybe not exactly. Okay, so it is a I created a dependent loop. I starts from 1 to n plus 1 because it is one base indexing, and j starts from 0 to ith index, I minus 1. Okay, now what will be our DPI? DPI will be maximum of, either we exclude this, or if we are including it, then if we include it, then we will have to add price. Now, since you see we are using a dependent loop, I will not add the length price of the length at which we are cutting. I will add the price of length of rod which is remaining. Okay, so this is very beautiful approach. So price I minus j minus 1. This will yield us, I minus j minus 1 will yield us the length of remaining rod which is to be cut. So see, dpj is what? Length of rod. I mean the price, and then price is what? Remaining rod. So you'll get the complete rod over here. You will not need any 2D DP matrix. You will just be able to do this in 1D array. So okay, 1 DP. At the end, I will just return it the last index of DP as we do in 2D. So as we are doing in 1D also. Let me submit it for you. And yeah, example test case is running. Let me submit it finally, and it should do the job. And yes, it does in pretty less time. As you can see, I tried it a lot of times, and using the usual DP method, I was able to solve only 1112. So last 3 test cases were remaining, and this 1D matrix helped me to solve it in pretty less time. Thank you. Have a nice day.